Good afternoon, Basa sir.
Ladies and gentlemen, a very good afternoon and welcome to the one-day seminar on recent trends in Internet of Things, organized by the Institution of Engineers India, Tripura State Center, under the aegis of Electronics and Telecommunication Engineering Division Board, IEI, jointly with Electronics and Communication Engineering Department, Tripura Institute of Technology, Narsingar, Computer Science and Engineering Department, Tripura Institute of Technology, Narsingar, Electronics and Communication Engineering Department, NIT Agartala, and Computer Science and Engineering Department, NIT Agartala. The program is coordinated by Computer Science and Electronics Telecommunication Engineering Division. In today's program, we are having the esteemed presence of our Chief Guest Engineer, C.K. Dhar, FIE, Deputy Director General, State Informatics Officer, National Informatics Center, Agartala. We are having the presence of Dr. Bijoy Kumar Upadhyay, Chairman, Computer Science and Electronics Telecommunication Engineering Division, IIT Tripura State Center. We are having the presence of Engineer Chinmoy Debnath, Chairman, IEI Tripura State Center. Dr. Shubhodip Bhattacharjee, Honorary Secretary, IEI Tripura State Center. May I request all our guests to come on dais, please. May I now request Chairman, IIT Tripura State Center, Engineer Chinmoy Debnath, to welcome our dignitaries on dais. Thank you. May I request Engineer Chinmoy Debnath, Chairman, IIT Tripura State Center, to present the welcome address.
Good afternoon. Respected chief guest of today's program, Engineer C.K. Dhar, the past president, who is also executive vice president of WFU, Engineer Ashok Kumar Basa, the vice president IEI, Engineer Sandeep Kumar Deb, the chairman, Electronics and Telecommunication Engineering Division Board, IEI, Professor G.S. Mondada, Engineer B.K. Upadhyay, Chairman, Computer Science and Electronics and Telecommunication Engineering Division, IEI Tripura State Center, Engineer Tapas Bhattacharjee, Advisor, Electronics and Telecommunication and Computer Engineering Division, IEI Tripura State Center, the Honorary Secretary, Dr. Shubhodip Bhattacharjee, the moderator of today's program, Dr. Suman Deb, our past chairman, past honorary secretary, participants, and fellow members. On behalf of the Institution of Engineers India Tripura State Center, I take the privilege to welcome all of you in this one-day seminar on recent trends in Internet of Things, organized by the Institution of Engineers India Tripura State Center under the aegis of Electronics and Telecommunication Engineering Division Board, IEI, jointly with Electronics and Communication Engineering Department, Tripura Institute of Technology, Computer Science and Engineering Department, Tripura Institute of Technology, Electronics and Communication Engineering Department, NIT Agartala, and Computer Science and Engineering Department, NIT Agartala. In fact, the Institution of Engineers India Tripura State Center has completed its 31 years of journey, and 1st April 2022 is the 32nd foundation day, including the period of Agartala Local Center, which was established in 1989 in ad hoc shape, but got recognition by the headquarters in 1991, 1st April, and upgraded to Tripura State Center on December 2008. So in connection with this week-long program to celebrate the 32nd Foundation Day, today is the 6th day, that is a one-day seminar on recent trends in Internet of Things. In this program, we have with us Engineer C.K. Dhar, FIE, Deputy Director General and State Informative Officer, NIC Agartala. On behalf of the Institution of Engineers India Tripura State Center, I welcome you, sir, in this program. We are really happy to have the kind presence of Engineer Ashok Kumar Basha, the first president of the Institution of Engineers India, who is also Executive Vice President of World Federation of Engineering Organization. In fact, very recently, he has been elected as Executive Vice President of World Federation of Engineering Organization. So on behalf of the members of the Institution of Engineers India Tripura State Center, I welcome you, sir, and also congratulate on election of this Executive Vice President of WFEU. In fact, in our today's program, we had invited Ashok Basaji, but due to some other busy schedule, he couldn't make time. But ultimately, on our request, he came for some period. He will leave after this deliberation. So, for his kind consent to be present in this program, in spite of his busy schedule, I once again welcome you and also thank for your kind acceptance. And we know that Ashok Basaji has special attachment or affection to the Institution of Engineers in the Tripura State Center in regards to many technical activity, particularly on disaster management. We got so much of support from him, and I hope in future days also we shall be getting this sorts of support from him. Engineer Sandeep Kumar Dev, Vice President of Institution of Engineers India, I welcome you in this program. Dr. G.S. Mundadaji, the Chairman of Electronics and Telecommunications Engineering Division, under which consideration the Institution of Engineers India Tripura State Center got this clearance to organize one-day seminar. I welcome you, sir, and hope through your involvement and guidance, the Tripura State Center may organize many such type of technical activity in future days also of this division. In our program, the special guest was Dr. Minalkanti Deborma, Associate Professor and Head Computer Science and Engineering, NIT Agartala. But due to some important meeting in the institute, he couldn't come to attend this program. In our today's program, we have with us the Chairman, Computer Science and Electronics and Telecommunication Engineering Division of IEI Tripura State Center, Dr. B.K. Upadhyay, who are coordinating this program at Agartala through hybrid mode. In our today's program, there are 4 presenters. Dr. Sujoy Dev, Associate Professor, Associate Dean of Student Affairs, IIIT Delhi, who will be delivering lecture on Edge Computing Enabling the Internet of Things. Dr. Suparna Vishwas, Associate Professor, Department of Computer Science and Engineering, Maulana Abul Kalam Azad, University of Technology, West Bengal, will be delivering on IoT enabled smart applications, different perspective. Sri Prakash Burman, Block Informatics Officer, Government of West Bengal, who will be delivering lecture on Internet of Things implementation. And the 4th presentation will be delivered by Dr. Abhishek Majumdar, Assistant Professor and Head of Civil Engineering, Computer Science and Engineering Department, Tripura University. In our program, the advisor of this division, Engineer Taposh Bhattacharya, is also present, who is guiding this division to organize the technical activity. I welcome you, sir. I welcome all the participants, the our past chairman, past honorary secretary, and the students in this technical program. Just I would like to mention here that during this 32 years of journey, the Institution of Engineers Tripura State Center is conducting technical activity, training program, and other many sorts of activity for which the government of Tripura has also given recognition to us in connection with this technical activity and other thing. And also we got the recognition from the headquarters in 2017, declaring us as a best center in C category state. And I am really happy to inform you that during this last council meeting, we have observed from the records of the Institution of Engineers, out of 125 centers, the position of Tripura Center is in third position in regards to technical activity during last year, when we had organized 65 technical activity. So I would like to mention here that it is only possible due to the attachment and involvement of our corporate members, committee members, obviously under the guidance of our headquarter. I hope the Tripura State Center, though it is a small center, may continue such type of technical activity in future days also, by which we are getting recognition by the government in our state as well as by the headquarter and others. And we would like to see that in future days also we may continue in this way. Thank you very much.
Thank you so much, sir. Engineer Chinmoy Devnath, Chairman IEI Tripura State Center, has highlighted and welcome all the guests. Now, may I take the privilege to introduce before the August gathering Engineer Ashok Kumar Basha, who is past president of IEI and now Executive Vice President, World Federation of Engineering Organization, WFEO. Mr. Basa was member of the Executive Council for the period 2015 to 2019. Besides, he is also the Vice Chairman of the Disaster Management Committee of WFEO. He had also served in many other important committees of WFEO, such as Governance Committee, Nomination Committee, WFEO UN Relation Committee, Committee on Information and Communication, etc. He was involved in drafting the rules of procedure of WFEO. He has also played an active role in the institution over a decade and having rich experience in different sectors. Ladies and gentlemen, it's a privilege really on our part to have the kind presence of Engineer Ashok Kumar Basha, the past President, IEI Executive Vice President, World Federation of Engineering Organization. May I request to present his views in form of speech. Engineer Ashok Kumar Basha.
Thank you. Am I audible?
Yes, sir. Yes, sir. You're audible.
Yeah.
Please continue.
Good afternoon, friends. Engineer Devnath Ji, Chairman of Tripura State Center. Dr. G.S. Mundapa, Chairman, Electronic and Telecommunication Division of Institute of Engineers, India. Past Chairman, past Honorary Secretary, members of the State Center, of Tripura State Center, and my dear friends from the fraternity. It is indeed an opportunity and privilege for me to address this August gathering. Friends, as you know, as has been pointed out by our chairman, my good friend, Mr. Devnath, Chinmoy Devnath, truly speaking, I have got a tremendous soft corner for Tripura State Center. You know, if I recall, when I was the president of Institute of Engineers India in 2014, in September, we had a council meeting there, and it was conducted wonderfully well. Not only the technical contents were good, but also the evening cultural program, I still remember. And as you know, Tripura is very much famous for the cultural evening. Similarly, as regards the Disaster Risk Management Committee, we had the experience of one of the best seminars on that day. I had a very hectic schedule on that day. I remember I was there for only 2 hours, but still then I enjoyed that. Now, when this Foundation Day ceremony was being conducted and Mr. Devnath had requested that I should be physically present in Agartala, initially probably I had agreed, but certainly there were certain limitations, and I requested Devnath ji to allow me to attend through the virtual facilities. Friends, it is my misfortune that I am not able to meet you personally, because Tripura is very much well known for the hospitality, and true from the heart, that's the best part of it. Friends, in this day of crisis of last 2 to 3 years, we have found that engineers have done a wonderful job. You know, if we meet today through virtual conferences, probably it is due to the COVID. They say necessity is the mother of invention. Not only that, necessity creates the zeal to get rid of the difficulties which we face during our day-to-day life. I would limit myself to two areas. One, the disaster risk management area, and the two is the World Federation of Engineering Organizations. Friends, World Federation of Engineering Organizations is a body which has been created in 1968 at the behest of UNESCO. And India is one of the primary members when the body was created. Now, after that, India had played very important role in this body. 2005 to 2009, the first executive vice president, our good friend Naveen Basoya's father, Mr. late B.J. Basoya, who was also a president of our Institute of Engineers India, was the first Indian to be elected as the executive vice president of WFEO. And indeed, it's a matter of privilege for me that it is Mr. B.J. Basoya who has contributed my presence, or rather, he was the creator. He made the channels for me to become a member of the Disaster Risk Management Committee since 2011. Now, from that day, I was a member of World Federation of Engineering Organizations. As you know, in WFEO, we have got different standing technical committees. There are 10 such committees, and Disaster Risk Management Committee is one of them. In 2015, I was elected as a representative of Institute of Engineers India to work in the Executive Council of WFEO. 19 to 21, I was there as the advisor to the president, and by God's grace, when the nominee for executive vice president was sought by the world body, Institute of Engineers nominated my name, and by the grace of Almighty and by the grace of the goodwill of all my friends from India, I could be elected, and the result was declared very recently on 9th of March in Costa Rica. Friends, India is doing a lot of works in the WFEO front. My friend Naveen Basoya, who has been elected as the representative in the Executive Council for 4 years, that is from 2019 to 2023, in an election, open election held in Melbourne. He is a member of one of the most important committees, the Governance Committee. I was a member of the Nominations Committee, and our past president, Mr. S.S. Rathore, is the chairman of the Committee on Information and Communication. And I'm glad to inform you that out of 10 standing technical committees in the world today conducted by WFEO, CIC, that means the Committee on Information and Communication, is one of the best committees which has been adjudged by the WFEO. Now, so far as the Disaster Risk Management Committee is concerned, I am the vice chair there, and very shortly, where a book has been published, and that is going to be released in the United Nations as a side event on 5th of May, wherein 12 speakers around the globe have been invited, and by God's grace, I am one of the speakers to be there during the release of the book. It is, most probably it will be on the virtual front, and this is going to be a very important activity of WFEO. I must say that so far in the disaster risk management, India is one of the leading country in the world. Though Japan is the most important country in this arena, but activities in India is not less. And that way I can say that 1999 super cyclone of Odisha and 2001 earthquake in Gujarat has taught us a big way how to manage disasters. And it is the Sindai Accord. Very recently in 2015 in Sindai, at the behest of United Nations, more than 140 countries congregated and decided how to go about the disaster risk management. Now the target is zero casualty. You'll be glad to know that now Government of India and all other state governments are now giving a topmost priority that whenever any disaster comes, there should be zero casualty. In that scenario, in that book, we had given the example of Odisha, because in the 99th super cyclone in Odisha, about 10,000 people have died, but in all other subsequent cyclones, the casualties have been drastically reduced, and the last one being 43, and in some cases it is zero. So this way, India is going at very high as per the Shindai Accord. So far as Tripura State Center is concerned, I was very happy the way things were moving. Of course, I am not aware how things are happening so far as the disaster risk management is concerned, but I am there to support Tripura State Center if such proposal comes. Now, another thing that why I like Tripura is, I remember a poem during our matriculation days, and to quote, in small proportions, we just beauty see, in small, short measures, life may perfect be. Tripura might be a state, small state, but smallness does not indicate the smallness in activities. I'm happy to learn from the chairman that out of 120 state center and local centers, Tripura has bagged the 5th position so far as the technical activities are concerned. That only speaks that it is the mind which is important rather than the size. So I once again congratulate Tripura State Center that they should carry on such activities in such speed so that they get such recognition. And I'll be happy when I hear that Tripura State Center should get the Best Center Award. Thank you very much for your patient hearing.
Thank you so much. Sir, you have always been a pivotal point to encourage the activities and instrumental in also accomplishing various activities. This encouragement is really a driving force for all of us to work together for the betterment of the state as well as for nation. Ladies and gentlemen, this program is really enhanced by the illustrious presence of our chief guest, Engineer Chayan Kantidhar, the speakers on various domains. May I take the privilege to introduce all our guests and speakers before the audience. Engineer Chayan Kantidhar is now the Deputy Director General NIC under Ministry of Electronics and Information Technology, Government of India. He graduated in Electrical Engineering and MBA in IT Systems. He has more than 30 years of experience in the ICT in conceptualizing, analyzing, design, and role in architecture of many ICT projects in the state of Tripura. He has played a role as solution architect in e-hospital in EHR platform, which is presently running in more than 600 hospitals across India, including AIIMS Delhi, NIMHANS Bangalore, AIIMS Bhopal, etc. He did many national and international courses on microelectronics, cybersecurity, etc. At present, he is the head of NIC in Tripura state. Ladies and gentlemen, today's speaker is Engineer Sandeep Kumar Dev, Vice President of IEI as a Chartered Architectural Engineer. He is the first Indian land valuation expert appointed by Asian Development Bank. He is the immediate past president of American Society of Civil Engineers, India section. He is the recipient of Eminent Architectural Engineer Award by the institution and 2 gold medals for the best paper, best editorial. He runs the Valuation Pathshala, where professional values from India and foreign countries participate to learn the art of valuation. Our next speaker, Professor Dr. Girish Srikrishnan Mundada, Chairman of Electronics and Telecommunication Engineering Division, IEI, graduated in engineering from Amravati University, Masters from MSU Baroda, and PhD in Wireless Communication Engineering from University of Pune. He has very rich academic experience of more than 28 years in different capacities of many colleges, and universities. He has published more than 20 papers in national and international level conference and journals. He is the author of 5 books on engineering, covering electronics devices and circuits, digital electronics, research methodology, analog circuits, semiconductor devices, etc. He was also awarded the best teacher by Pune University. Our next esteemed speaker, Dr. Sujoy Dev, Associate Professor, is an Associate Professor of the Electronics and Communication Engineering Department at Indraprastha Institute of Information Technology, that is IIIT Delhi. He received PhD from the School of Electrical Engineering and Computer Science, Washington State University. Before his current position, he worked as at Intel Labs, Hillsborough. His major awards and achievements include DST Inspire Faculty Award, Outstanding PhD Student Award in Computer Science and Engineering from Washington State University, winner of Indian US Grand Challenge Initiative for Affordable Blood Pressure Measurement Technology. He is a senior member of IEEE. His research interests are broadly in the areas of power and performance efficiency and reliable networks on chip communication fabrics, heterogeneous system architecture, hardware for deep learning, low-cost biosensors for preventing healthcare. Our next esteemed speaker, Dr. Suparna বিশ্বাস, an associate professor and head of the Department of Computer Science and Engineering in Maulana Abul Kalam Azad University of Technology, India. She completed her ME and PhD from Jadavpur University, India. She had been an Erasmus Mundus postdoctoral research fellow in Clink project in Northumbria University, Newcastle, UK. She has 2 granted international patents for innovation in IoT-based health monitoring. She has authored a number of research papers in reputed journals and conferences of international repute. Her areas of research interest include Internet of Things, machine learning, security in healthcare. Our next speaker, Sri Prakash Burman, a PhD research scholar in the Department of Computer Science and Engineering, University of Calcutta, West Bengal, India. His research focus on IoT security, communication security, Internet of Medical Device, and disease prediction and alert system. Our next esteemed speaker, Dr. Abhishek Majumdar, is an assistant professor in the Department of Computer Science and Engineering, Tripura University. He obtained his B from Tripura University, MTech from Tezpur University, and PhD from Assam University. His research interests are mobile computing, IoT, and AI. He has published many research articles in international journals and conferences. He has also published many book chapters under reputed international publishers. Ladies and gentlemen, now may I request Dr. Bijoy Kumar Upadhyay, Chairman, Computer Science and Electronics Communication Engineering Division, IEI Tripura State Center, to present his speech.
Thank you. Good afternoon, one and all present in the one-day seminar on recent trends in Internet of Things in physical as well as in virtual mode. This program is being organized under the aegis of Electronics and Telecommunication Engineering Division Board of the Institution of Engineers, India. Locally, it is being coordinated by Computer Science and Electronics and Telecommunication Engineering Division of the Institution of Engineers, Tripura State Center. We are delighted to organize this program jointly with the 2 institutions of repute from the state. One is NIT Agartala and other is TIT Narsingar, where the Computer Science and Electronics Department of both the institutes are participating as a joint organizer of this program. The respected chief guest of the program, Engineer C.K. Dhar, FI, Deputy Director General and State Informatics Officer, National Informatics Center, Agartala. Honorable Past President, IEI and Executive Vice President, World Federation of Engineering Organization, Engineer Ashok Kumar Basa, respected Vice President of the IEI, Engineer Sandeep Kumar Dev, Honorable Chairman, Electronics and Telecommunication Engineering Division Board, the Institution of Engineers, India, Professor Dr. Girish Sri Kishan Mundada, respected Chairman of the Institution of Engineers, Tripura State Center, Engineer Chinmoy Devnath, and Honorary Secretary Dr. Subodip Bhattacharjee, Engineer Tapos Bhattacharjee, Advisor of Computer Science and Electronics and Telecommunication Engineering Division of the State Center, respected panelist in today's program, Dr. Sujoy Dev, who is Associate Professor and Associate Dean of Student Affairs, IIIT Delhi, Dr. Suparna Bishwas, Associate Professor and Head of the Computer Science and Engineering Department, Maulana Abul Kalam Azad University of Technology, West Bengal, Sri Prakash Bormon, Block Informatic Officer, Government of West Bengal, Dr. Abhishek Majumdar, Assistant Professor and Head, Computer Science and Engineering Department, Tripura University, Dr. Suman Dev, Assistant Professor, Computer Science and Engineering Department, NIT Agartala, who is also moderating the program, respected past chairman and honorary secretaries of the Institution of Engineers, Tripura State Center, members of all levels of the Institution of Engineers, faculty members, dear students, my colleagues in Computer Science and Electronics and Telecommunication Engineering Division of this center, ladies and gentlemen attending this seminar either physically or virtually. On behalf of the Computer Science and Electronics and Telecommunication Engineering Division of this center, I take this opportunity to extend our warm welcome to all learned people present here. It is really a blessed day for us to have a galaxy of renowned personalities, expertise from the engineering fraternity who have accepted our invitation to grace this occasion with their valuable speeches and presentations in spite of their busy schedule. We express our sincere gratitude to all of you. Today's topic for discussion is recent trends in Internet of Things. As we know, the Internet of Things refers to a system of interrelated, interconnected objects that are able to collect and transfer data over a wireless network without human intervention. The thing in IoT can be any device with any kind of built-in sensors with the ability to collect and transfer data over a network without manual intervention. Since IoT allows device to be controlled remotely across the internet, thus it created opportunities to directly connect and integrate the physical world to the computer-based system using sensors and internet. It's really an exciting field of multidisciplinary engineering. We all are eagerly waiting to listen from the expert, which I am very sure will enrich our knowledge about the current trends in the field of the IoT. Thank you all.
Thank you, Dr. Bijay Kumar Upadhyay, Chairman, Computer Science and Electronics and Telecommunication Engineering Division, IIT Tripura State Center, for an illustrious view of his thought. May I now request Professor Dr. Girish Srikishan Mundada, Chairman, Electronics and Telecommunication Engineering Division Board, IEI, to present his speech.
Thank you. Good evening to all. Congratulations to the Institution of Engineers, IIT Tripura State Center, on its 32nd Foundation Day. Respected in absentia President IIT, Dr. H.O. Thackeray sir, our mentor, past President IIT and Executive Vice President, of World Federation of Engineering Organization, Engineer Ashok Kumar Basa sir. In absentia, our two Vice President, Sandeep Dev sir and VB Singh sir. Our CATE Chairman, Dr. G. Rangnath sir. Two guests today, C.K. Dhar Saab and Dr. Bijendra Upadhyay Saab. Tripura State Center Chairman, Engineer Chinmay Debnath sir, Honorary Secretary of the Center. The Tripura State Center Committee members, organizers, Director Technical, Engineer Sudip Chakravarti. In absentia, our SDG Major General Sale sir, all invited guests, speakers, and participants. I am indeed privileged to be with you all today. And I thank II Tripura State Center for organizing this one-day seminar under the aegis of ETDB of IER on topic recent trends in Internet of Things. And that is how I got this opportunity to speak on this occasion and listen many resourceful people who will be delivering their speeches and knowledge today in this seminar. Internet of Things is a buzzword today, fueling its expansion further with the advent of artificial intelligence, machine learning, and data science. I am sure the presentations and deliberations made during this seminar will be of immense help to the ET engineers in particular and young engineers who are looking to interdisciplinary approach through this seminar. I wish this program every success and thank all those who have taken efforts to shape this seminar. The Electronics Telecommunication Division Board of II will always encourage the technical activities all across nation that will prove to be beneficial to the engineering fraternity. I am very happy to note that this Foundation Day is being celebrated by Tripura State Center by organizing a week-long technical fest. That shows the tremendous passion towards the technical activities of this center. And as our past president has said, that it is not the size, but the state of mind matters. We all need to learn from you because you have already showcased by scaling third position across all 126 centers. So I congratulate the leadership and definitely it's a very proud moment for all of us. Wishing you once again all the best on your foundation day. Thanking you organizers for giving me this opportunity. Thank you.
Thank you so much, Dr. Girish Srikrishnan Mundada, Chairman, Electronics and Telecommunication Engineering Division Board, for a wonderful encouragement for the activity.
Thank you.
May I now request our chief guest of today's program, Engineer C.K. Dhar, FIE Deputy Director General and State Informatics Officer, National Informatics Center, Agartala, to present his speech.
Good afternoon to all. Chairman, IIT Tripura State Center, Engineer Chinmay Debnath ji, past President, III, Engineer Ashok Kumar Basa ji, Chairman, Electronics and Telecommunication Engineering Division, III, Professor Girish Srikrishnan Mundada, Vice President, III, Engineer Sandeep Kumar Dev, our unit chairman, Dr. Vijay Kumar Upadhyay, other distinguished past president, members and guests present here in this hall and participated online, students, faculty members, my colleagues from DIT. It's really a privilege for me to be present in this seminar on recent trends in Internet of Things. Incidentally, I may say incidentally because when we passed undergraduation course, computer science engineering division was not there. So we did our electrical engineering. Even then, we got opportunities to move to microelectronics. Then, of course, through a job, I've been working in ICT field for the last 3 decades. I have seen how it has evolved in the country during last 3 decades. I would like to just recall when we started our IT journey in NIC, it was a standalone PC. Many of you probably may not be even knowing standalone PC. Then we moved to client server architecture based application software. Then we moved to data center, that is hosted application where this internet has reached. That is the one of the turning point. Data center, internet. Then of course now cloud as a service. How much we have achieved, cloud characteristics is a subject for debate, subject for research. I will come into it. Then another side, from application side, as a practicing software engineer, as a solution architect, we have seen information systems, management information systems, then products, then platforms. Here again, turning point probably is platforms, where our today's topic, recent trends in Internet of Things, is a closely linked. Platforms and ecosystem probably going to give a different shape how we live, how we actually pass our day-to-day activities. Why I'm saying this particular thing here, this platform and ecosystem and Internet of Things is closely actually bounded. These are closely linked in the sense that if we recall internet for people, it was the internet for people, now internet for things. This is probably a simple definition. We may distinguish this particular shift, internet of for people, internet for things. That is internet of things we are talking about today. In this today's one-day seminar, there is a distinguished expert speakers are there. We will know a lot of things. We will come across probably a lot of issues this particular Internet of Things facing nowadays, and we all will enrich ourselves. The point probably, if we come to Internet of Things, we may precisely divide this Internet of Things into 3 specific areas. First of all, the concern area for everyone, specifically academics here, they have to think seriously about it. Internet of Things, sensors, actuators, precision level, how far we have achieved. Digital instrumentations probably will, if it is further improved, will make dramatic shift or adoption of Internet of Things into our day-to-day activities. There is a still concern, digital instrumentation, precision level, probably perfection is required. In particular, in medical instrumentation, Internet of Medical Things, this precision is a prerequisite. This is one concern area. Then sensors are going to acquire huge volume of data. Huge volume of data, how we are going to handle this huge volume of data, how we are translating this huge volume of data into actionable data points. The volume of data, how will pass through data pipeline is a serious issue, because in 2021, around 11 billion devices are connected. By 2025, probably 30 billion devices will be connected, though it was downgraded by Gartner, around 27 billion devices will be connected. So this Internet of Things going to generate huge volume of data. How we are going to basically handle this data going to be a second challenge. And security, when it is IT, security is always the issue. There is no measuring metrics, there is no baseline, so it is an evolving dynamic industry. Academics here, we have to solve, as a practicing engineers, we have to solve these security issues. These are the three probably areas where we have to basically concentrate if we are to reduce. Basically, the more we are going to adopt Internet of Things, this interaction with the device is going to come down dramatically. That is human to machine and machine to machine. More and more devices we are going to, integrate things. We are going to integrate this machine to human interaction is going to come down drastically. That is again a challenge area. I'm not going into it. Now, precise point is digital instrumentation, sensor, measurement instrumentations. Until and unless these areas are taken care seriously, this going to be, the way Gartner has reduced adoption of, IoT or IoT devices, or even in retail industry, even in transportation industries, that we will know through our expert speaker, application opportunities, areas, these all areas are there. So really, to conclude just to set context for today's seminar, I would like to thank organizers for giving me these opportunities to participate, listen, expert speakers on Internet of Things. It's really grateful for all of you. Thank you.
Thank you so much. The chief guest of today's program, Engineer C.K. Dhar, FIE, the Deputy Director General and State Informatics Officer, National Informatics Center, Agartala. Now, may I welcome the presenter and the keynote of today's program, Dr. Sujoy Dev, Associate Professor, Associate Dean of Student Affairs, IIIT Delhi, on the topic, Edge Computing Enabling the Internet of Things.
Thank you. Hope I am audible. Just give me a moment. I'll share my screen. Is my screen visible?
Yes, it is visible. Please make it full screen.
All right. So first of all, thank you. Thank you everyone for this organization and wonderfully organizing all this event, especially the Institute of Engineers, the Tripura section, and all the dignitaries who are available. Today I'll be, I'm hoping you guys are seeing the full screen presentation.
Yes, it's absolutely fine. Please go ahead.
Okay. So today, in this given time, I'll try to basically pose some questions and also try to motivate the students available to look into this buzzword Internet of Things and go a little bit deeper and explore that what we can do differently to make those solutions which are enabling Internet of Things ubiquitous, more Indianized, more relevant for our purpose. And that's why I think there is a huge push to basically come up with solutions with off-the-shelf devices available and build Internet of Things related solutions, which might have been designed for a completely different scenario. For example, if I look at home automation in US, the kind of requirements there and the kind of requirements which maybe a household in India will require are completely different. So that's why I think we need to go few steps backward and try to understand the problems from the first principle and try to basically find indigenous solutions. And I think we have all the potentials and we can do wonders if we look into the nitty-gritties about what we are trying to solve and how we are solving it. Now, one of the enablers of Internet of Things, or why suddenly we see so many connected devices, because our compute power has now calculated to very small form factors, which we call, like wherever earlier there were sensors only connected. Let's say I had a system where there were 10 sensors connected. Those sensors were pumping data into a centralized compute power, which was making some decisions, etc. Now what we are doing, we are putting the compute power along with the sensor, and we are calling it an edge device. So it's not only a sensor, it has some intelligence as well. And that is sending the data kind of autonomous in an autonomous manner, and we can collect a lot of such data and make use of those data to take intelligent decisions. And I'm really thankful to today's chief guest, C.K. Dhar sir, for pointing out this problem very nicely, that we really need to improve on each and every part. For example, from sensing to how we maybe what kind of instrumentation we use, and then how we make sense of that data, etc. So we, myself, Sujay Dev, I'm working at IIIT Delhi, and we in our group, we call our group as Advanced Multi-Core System Lab. You can see the logo here, AMS Lab, and we try to answer or ask these questions and try to see where we can contribute. So this part we all are familiar with, how our computing devices evolved. And as I have highlighted, that this evolution is primarily the reason why we are talking about this topic on recent trends in Internet of Things. So we have seen the mainframes, or basically we have heard about mainframes, and then we have seen our personal computers. Now we are carrying, everybody is carrying a computer with us in the form of a smartphone. Many of us are carrying multiple basically devices which are smart, for example, a wearable smart watch, etc. And as chief guest also have rightly highlighted, that the expectations are that we will have many more connected devices going forward, and those connected devices are basically producing a lot of data. Now, to make sense of all this data, we need compute power. Now, if we go back to the basics, that how we achieve compute power, or how things have actually evolved like this, I think today, instead of, I'll try to touch base on some of the recent things, but instead of directly going there, I would like to go and step back a little and try to understand how this evolution happened. Like how we moved from mainframe to a, let's say, smartwatch, or a very smart, let's say, CCTV camera, how we have reached there. So fundamentally, if you look at the main driving force behind all this evolution, is that we start with some application. So I have some application in mind. Now that application need to be solved using some physical phenomena, some physics properties. Now, of course, the physics property we are using is in the form of a switch, and the switch is designed using semiconductor, etc. So we are all familiar with the different abstraction level of computer architecture. So basically, but the journey from application to physics is a long journey. And if we do not have proper mechanism to basically abstract out things, then this application to physics journey is almost impossible to make. Because if you ask a student that I want to build a smart camera, so you have given him the application. Now, if I don't give him enough abstractions, like where he can abstract out, maybe he will take a existing camera and make it smart. So then the abstraction layer is basically you assume that there is a camera, basic camera, and you add smartness to it. But if we don't give him that, and if we say that, okay, you use the physics principle, find out how a camera sensor works, how light is concentrated on the sensor, how the bits of the pixel changes, and then so he will spend maybe his whole several years in understanding how a camera works. Then he will think about how to make it smart, etc. But very luckily, all these abstraction layers are very well defined. So, and because of that, basically I can come up with an application, and that application will drive how should the algorithm be written, what language I should use, what operating system, etc. I should use. And then comes the basically very important questions like what kind of computer I should use, like what kind of instruction set architecture I should use, like whether it should be an open source instruction set architecture like RISC-V or an ARM-based system. Then how the instruction set architecture is one thing, then how the microarchitecture of that instruction set architecture will be developed. For example, we know that all our laptops are primarily working with mostly x86 instruction set architecture, but the same x86 architecture can produce performance, very high performance in the form of, let's say, i7 processor. Similarly, same instruction set architecture can also produce a Atom processor, which is very lightweight, maybe used in handheld devices, etc. So that is defined by the microarchitecture. So what kind of performance I want, what kind of cost I want to give, and all these things will define the basically the microarchitecture will define that. And then the other, basically we can go into lower abstraction levels like gates, circuits, devices. So our sensors will come under this, basically devices, circuits, how our circuits will be designed, etc. So IoT actually touches upon all these abstraction layers. So it's truly a multidisciplinary field where you have to find out an application, and you have to find out what sensor to use, what compute power to use, and how basically I can solve that problem. And the good thing is that the application gives me requirement. For example, recently we are all basically trying to use AI, ML kind of algorithms in every possible scenario we can think of. So basically that requirement is driving that what could be the architectural changes, what could be the physics level changes, or what kind of transistors we should use. And basically the constraints are coming from the technology. For example, I can't switch a transistor beyond this speed, or I can't make a transistor smaller than 3 nanometer or so. The bandwidth between a processor and a memory can't go beyond this. So even if I want to, let's say, process a video of 60 frames per second speed, I might not be able to do it because of the bandwidth limitation between processor and memory. So the constraints define like how much I can achieve. And then in the middle, the architecture tells us that how we should find a balance between the two. So I have an application requirement, I have a technology constraint, and the architecture actually tells us that how we can take them along and find out the best possible solution. So whenever we think of designing any IoT system, I think we should take this approach and keep this approach in mind and try to find out a basically suitable solution. Many a times in the rush of getting things done, we maybe skip some of the fundamental things. I think that's where we also miss a lot of opportunities to build something really exciting. So especially for students or people who are planning to work in this domain, I would encourage them as much as possible to look into the first principles and try to find or try to use their solution wherever from this kind of analysis. Now, okay, so going forward, I'll just try to also highlight some of the things which are very relevant for us to know. So there is a huge requirement that we come up with our own hardware solution. So we have done wonders in terms of software, especially in terms of software development, software service providing, etc. But we have the capability to do similar kind of thing in the hardware as well. And that's why there is a lot of push to come up with maybe using the open source ISAs, instruction set architecture, some processors which will cater to our needs. So, and there is a very, very important need for that because of all the scientific and the strategic developments. We want our own processor, our own hardware to be deployed. Otherwise, there is always a risk of somebody denying what they have been providing now and putting us in a very bad situation. So that's why we should try to develop that skill. And basically, the compute power is required in every aspect. And if you guys search that what is the fastest supercomputer today, you will see that, and you can very easily search that in the top 500 list. You will see that the fastest supercomputer, which is a Japanese supercomputer, it can support exascale performance. So exascale is 10 to the power 18 floating point operations per second. So that's really huge. And I would also encourage you to go through the whole list of top 500. You will see that our supercomputers are not very close to the top, let's say 50, or I think the fastest we have is around top 8 ranked around 80 or so. So we can do much better. So that's one end of the spectrum where we are talking about huge compute powers. On the other end of the spectrum, actually, where the edge computers are there, many times we are tempted to use, let's say, Arduino or a Raspberry Pi to find out our solution. But if you look closely, you will see that the Arduino or the RPi has a lot more redundant things which you really don't need for your current application. So you can build your processor from scratch. You can introduce new instructions depending on your need. And that can give you a much better optimized solution, which will be optimized in terms of power, in terms of your performance, security, and whatnot. So please try to look deeper and try to find out solution which will be a little beyond the off-the-shelf solutions. And of course, we all know that we are way beyond the single processor systems because of the power related power wall. And that's why we have moved to many core, and many core has opened up new solutions. And we are in an era where basically we are seeing more and more processors with many cores. And with many cores, the possibilities, the opportunities of contribution from in terms of research, in terms of coming up with new designs, etc., are becoming more and more. And one of the very huge challenge of having many core processor is how do you share information among different cores efficiently. And that's one of the key areas where we are focusing on in our research at IIIT. Just to give you some glimpse, like if you look back, the 1 teraflop sustaining supercomputer in 97, in the year 1997, took a whole huge hall with 72 cabinets, etc. Same thing was achieved using Intel's Knight's Corner processor in 2011, designed in 22 nanometer. And we are now talking about 3 nanometer, 5 nanometer. So you can imagine the kind of compute possibilities are there. Of course, there are huge challenges also. And exascale is one marvelous example. And if you also look at recent trends in terms of how the compute platforms are designed, like you will see that the era of general purpose cores in a multi-core system is gone. So we will find a lot of accelerators. Just to highlight some of them, this is an Apple system on chip A12. Those of you who are using iPhone or let's say MacBooks, you will be familiar with this processor. Now, if you look at the dimicro diagram here, if you look closely, you will find that almost half of the chip is basically filled with specialized accelerators. So no longer you are using general purpose multi-cores. You are having a lot of accelerators. They are designed, optimized to do a specific task. Now, when you have them in your system, designing your system becomes much more challenging, because how do you share information? How do you basically allocate? Task allocation becomes very, very interesting. So all these challenges we are looking at in our lab. Just a pictorial representation about how the number of accelerators are increasing in Apple processors, and this trend will continue going forward. There also results in a lot of other challenges. For example, right now our SoCs are looking like this on the left hand side. So there are basically, these are essentially heterogeneous SoCs. So there are CPU cores, there are GPU cores, there are accelerators, there is a network on chip which interconnects them. There are on-chip memory. Sometimes you will find FPGAs also there for reconfigurability, etc. So this is how the current SoCs are looking like. And going forward, the number of accelerators will be much, much higher. And that also will increase a lot more challenges. For example, how do you share resources among them? How do you ensure that none of these accelerators are rogue and they can create some kind of security breaches, etc. So in some other time, whenever we have appropriate platform, I can go in detail, but I wanted to just give you a glimpse of how the current state-of-the-art processors are looking like. Also, as one thing I would quickly highlight is about our basic processors. So our basic processor follows this von Neumann architecture, or basically stored program model, where you have your program as well as data stored in memory. You have a processor. So processor requests for data, it gets the data, executes, and then stores it back into the memory. So for a small system, this works fine. You can connect your processor and memory using a bus. No issue with that. And that's how our original systems were designed. But now we are talking about multi-core systems. So now how does this multi-core system look like? So you have a lot of processors. And so though in this figure, we are showing only homogeneous kind of processors, but in reality, you will find that these processing elements are also very heterogeneous. And now if all of them share a single bus, as we all know, buses are basically shared medium, where you have to reserve the bus and then only you can communicate. So, and at a time, only one pair can communicate. So this becomes a very unscalable solution. So when you are talking about hundreds of processing cores in your system, etc., bus is not going to help. So what is the possibility? So the possibility is basically you, so bus is your bottleneck. So possibility is something called network on chip. Now, what is network on chip? So basically you put your processors, and along with the processor, you put a router, and then these routers are connected among themselves, forming a network. Now, any processor or any node needs to communicate something with another node. They can go via, so they will push the data to the router. Router will look at the source and destination, and it will figure out like how to send the data to the destination. So this way you are decoupling computation with communication. And that has been a very, very significant change in terms of how we design processors. And because of that, network on chip is now a well accepted concept, and most of the let's say processors which are having more than let's say 16 or 32 cores, they are coming with network on chip. This I think slide illustrates how the message moves from one location in the network on chip to the other location. So basically the communication is essentially multi-hop. Okay. And there are of course challenges also, because sometimes if your network on chip becomes too large, then your communication also takes longer. So you can come up with basically other alternatives, like having some additional links which will act as highways, etc. So in the interest of time, I think I'll skip some of them. So one solution is basically you can have some wireless interconnects which can basically make this multi-hop communication little more efficient. Now, another aspect of this thing is as systems are becoming so complex, there is a possibility that you will miss something, you will add some errors, or you will have some errors in each step of your design. And that's why, though we have a lot of verification, etc., done before you basically come out with the silicon, but there is invariably some problems when the silicon comes out, and that's where the post-silicon validation becomes very, very important. So especially for this kind of complex system. So our group is also working on interesting solutions for post-silicon validation. So I'll just quickly summarize here. So what we discussed, we discussed about the Internet of Things, and how from first principle we should look into whatever solutions we are trying to generate. For example, we look into the application, and then we, from the different abstraction levels, we try to gather what will be the best solution. We also try to optimize whatever solution we are trying to use at each level, from sensor to the processor. We should not be taking anything for granted. So just because Arduino is there with all its shields, you might feel tempted that, okay, Arduino with this shield will work to my solution. It might work, and both of these things are required. Like, you can come up with some prototype quickly, etc. But if you are going for a more thorough analysis, thorough development, then you should go deeper, understand the architecture, look at the bottlenecks, try to find out how you can solve them. Also look at the challenges related to multi-core, the way the multi-accelerator systems are developing, and what are the design trends there, what are the security related issues, what are the verification related issues. So all these things are very, very interesting to look at. So Internet of Things is a very, very vast topic, and of course it is a reality, and we have to live up to that reality, and for that we have to have the know-how. So I think we all should invest a lot in developing that know-how, so that we don't take anything for granted, and just use the things which are available to us. We should come up with our own solution, which are optimized for our own purpose. So these are few collaborators which I'm working with. Some of them are universities. We have a project with National Supercomputing Mission. We have a project with DRDO, SARB, and CNRS in France, and other universities in US. So this is a glimpse of the thing which our recent publications, etc. there. I'll encourage you to maybe visit our webpage to know more about it. And I'll be very happy if there are any questions or any clarifications. And I once again thank the organizers for this wonderful opportunity. And I look forward to physically be there and interact with all of you. Thank you.
Thank you so much, Dr. Sujoy Dev. And that was a very nice, short illustration of really the workable model of recent trends in Internet of Things. It is very true. Most of the cases in hardware level, we are dependent on other countries or other developed labs. It is a time for us to make our actual know-how so that we can build our own instruction set to be executed on our own machine. Primarily, you have highlighted all our students about the ability where students can extend their ideas, the faculty members, the researchers, and also the administrators, that how a collaborative system can be generated worldwide and how people can involve themselves into the real development. I'm sure there are a lot of questions, and if any questions are there, because there are both physical and virtual audiences, we will send you the question and we will try to interact in the next session. Thank you once again. And definitely we are also looking forward to make this type of interaction physical, but largely widespread through the online mode. Thank you so much. May I now request our next presenter and speaker, Dr. Suparna Biswas, Associate Professor, Department of Computer Science and Engineering, Maulana Abul Kalam Azad University of Technology, West Bengal, on the topic IoT-enabled smart application, different perspective.
Thank you. Hello?
Yes, please, you are audible.
Yeah, am I audible? Okay, okay. Very good evening to one and all. And may I share my screen?
Yes, please.
I'm not able to share. Is the screen share off? Oh, okay, okay. Now it's fine. Yeah. So is my screen visible?
Yes, it's visible. Please make it full screen and
Okay.
thank you.
Yes. Yeah. So very good evening to one and all the distinguished speakers, the organizers, respected engineers, faculty members, scholars, students, and one and all whosoever are present in this event, both in physical and in online mode. So myself, Dr. Suparna Biswas, already there was a nice introduction. So I am thankful to the organizers for giving me this opportunity to talk something related to IoT and its and the smart applications, focusing different perspectives. As the time is limited, so maybe I will be highlighting more on the IoT applications that are ensuring quality living with the technological support. Now, I am Associate Professor in the Department of Computer Science and Engineering, Maulana Abul Kalam Azad, University of Technology, West Bengal. So this is the way I'm going to spend maybe next 20 minutes with the respected audience. Here the content is organized in this way, like a brief introduction, as we are all aware what IoT is. So I will just touch upon on this with the layered architecture and the different design perspectives of IoT based smart applications. And with the highlight of the IoT enabled smart applications, I will move on to specifically the IoT in healthcare, and that leads to the quality living of human beings, specifically to the elderly people or people suffering from prolonged diseases who need continuous monitoring or remote monitoring. And without manual support, how IoT can help in monitoring and ensuring a quality living with the technological support, and the references that I have used in preparing the PPT. This is a popular Gartner technology trend which gives us the advancement in technology and the position of the technology in terms of it is new or it is going to establish in near future, or this kind of prediction and focus is well accepted. And from this reference, we can see that IoT is now, by this time, is a established technology. And with this, the IoT-based applications, designing, implementation, and while doing that, different challenges, issues, perspectives are there, and that is leading to the meaningful research. And ultimate implementation can only lead to the actual implementation in the human quality living. So that is the societal benefit part of the IoT. So basically here IoT connects billions of things, and here the things can be anything and everything in this world, and things must be smart, and smart is now a dictionary definition. Now the main perspective or the main focus by which this technology is becoming popularized is because of its ubiquitous properties, like anytime, anything, and any place communication, computation, and connection. And the IoT needs particular intelligence support, like because of handling of smart data. Now, what is smart data? We will come to that point. But the intelligence support is required because the graph shows that IoT devices generating data over the years is increasing exponentially. So to handle with the data, we are all are aware with the term big data. The with efficient handling of data, we need some intelligence support. And IoT is a layered architecture, as the distinguished speaker in the previous session has already mentioned about the abstract layers. So here it is a very illustrative view of the layers, like how the physical world is getting converted into the information world. Like the data which is sensed or acquired by the physical world is reaching through the communication world to the information world, where the meaningful or the significant information is getting extracted by efficient and intelligent processing of the data which were acquired from the physical world. And ultimately, what is the purpose? Purpose is for the data access and decision making by the authorized entity. Now, as the term authorized entity, so the security is also one of the associated wing of research or the implementation perspective of IoT-based applications. So we'll not elaborate on the security part. Rather, I will just focus on how the IoT-enabled applications can be applied for societal benefit. So the IoT perspectives, mainly two are being highlighted over here, as the reference is also given. Like one perspective of IoT is the different research agenda to ensure the development of a trusted, secure, reliable, and interoperable net-centric computing environment. And while doing this, we can accomplish several goals, as I will highlight just now. And another perspective is IoT can come or is coming as a human agent, human extension, and in some applications, human complement. So human complement is a huge task, but it has already become as human agent and human extension in different applications, real life applications. Now, while we connect with the first perspective, several goals can be accomplished or has to be accomplished in terms of identifying architectures and control strategies, develop protocols for information security, implement robust software assurance techniques for MPCDs. What is that? Mobile personal computing and communication devices. Analyze and predict the behavior of large net-centric societies, facilitate seamless interoperability, which is very much important because there are several heterogeneous and hybrid networks, analyze data and identify patterns, generate proper human-computer interaction protocols, etc., etc. And while we consider the second perspective, there we find that there is ample scope, or why we will focus on this perspective here. I will focus on this perspective is next few slides. Like there are so many data, heterogeneous data available from the physical, cyber, and social data. And these data plays a role in helping humans gain better insights and actionable intelligence. Now, humans with their intelligence, they are not well equipped to deal with the massive amount of data. Now, what could be the alternative and how the data to be processed? The highly contextualized, like context sensitivities and personalized information that's also actionable. That is, the smart data has to be transformed from the huge amount of data. And if the smart data gets associated with IoT network, that forms the smart IoT network that leads to take up a role as human agent or become a human extension and human complement. And human cognition and perspectives achieved through processing of data in different forms like text, video, like we process, or humans in general can process. We can apply our cognition and we can process data in different format, like it can be text, it can be video, it can be image, it can be speech, whatever. That can be applied for machines to process the data in intelligent manner. And for that, the IoT has to be clubbed with artificial intelligence, so that together with the IoT can come up with the IoT human agent, human extension, or human complement. So that is our ultimate goal to reach with. The IoT applications basically are smart means self. This is a well-defined term in the computer science dictionary, like means self-monitoring, analysis, and reporting technology. So how it happens in IoT, like there are three layers or three worlds basically. One is the sensing layer, where the sensors are actually doing the self-monitoring or the analysis, self-monitoring. And the data is getting transmitted over the communication world to the processing layer for the analysis part. And after the analysis, whatever control information is getting generated, actually based on that, the control part or the actuation part takes place. So sensing layer, heterogeneous layer, and processing layer through which we can reach to a particular decision. Now, while we design different IoT-based smart applications, there are several design perspectives or constraints you can see. Because ultimately we know that all the devices, specifically the IoT devices, are mostly battery operated. So energy is a big concern. Hope I am audible and my slides are visible. Hello?
Yes, yes.
Yeah,
Please go
okay.
ahead.
Yeah, thank you. Now, another, for many applications, this latency is very much important, specifically the time critical application like healthcare. Their latency is a big concern because the data are time critical data. Now, throughput is one of the important concern while we design the IoT applications, and that also this throughput, which is defined per unit time, we know. So, for a successful data delivery for any system is a expected performance parameter. Here, it is also of equal importance. Scalability always in IoT based smart applications or any systems, the main advantage of this kind of smart applications is the scalability per scope. In future, if you have to extend the system or the network, then IoT has that capability to support it. Topology, like how the node to node communication pattern will take place, that is also very much important. And security privacy is inherent part, because the sensors are vulnerable to the physical attack as well as the logical attack, and also the heterogeneous network through which, or the shared medium through which, the important time sensitive data, privacy sensitive data are being transferred, is also vulnerable to security attacks and threats. And also in cloud, though there are some inherent default security mechanisms are there, but as these are shared resources, so in every point there are security vulnerabilities. And while designing any IoT based smart applications, security or prevention or measure has to be taken. And while doing this, we have to be careful about the properties like heterogeneity, interoperability, pervasiveness, edge or cloud computing, through which the processing of the data can happen at the local end or the remote end. And always the systems are evolving over the time, so the application to be designed must be supportive to the evolution of system based on the change or demand or the change of the requirement of the users over the time. Now, these are the some glimpses of smart applications that are governing our daily life and that are helping us to lead a quality living with the help of the technology. And some of the illustrations I have kept just for the visibility, like it can be smart energy, it can be smart environment like pollution monitoring, it can be smart waste management, and smart structural building health can be monitored. Smart traffic control, which is now becoming a need, very much need in the society, and smart parking. Along with this, the smart healthcare is equally becoming important, specifically if in case of prolonged monitoring of the elderly people or people suffering from some prolonged diseases can be done through the remote monitoring. So here just a representative diagram or the framework that we use in our work, like this is called wireless body area network. The sensors, these are the biophysical or biomedical sensors that are attached or implanted or wearable to the human body, and the sensors are sensing several vital parameters, and through the coordinator or the edge device, it is getting transmitted to the cloud medical server at the remote end. There, the applying the intelligent algorithms, artificial intelligence or machine learning or deep learning based on the nature of the data or the type of the data, size of the data can be applied. And from there, whatever significant information extraction is being done, that can be sent to the doctor or the practitioner who is sitting at the remote end, or the hospital authorities or the drug designers, the pharmacies, whosoever need the information can be shared with them, and the processing can be done at remote end, edge end, or at the cloud end. Now, in our research group or the project that I am handling as a PI and also a co-PI is targeted with the smart healthcare. And security perspective is also associated, but for time limitation, I haven't kept that. So what we are doing, just a few 2 or 3 works I have kept in the slide, so that what we can achieve with these knowledge associated with IoT, sensors, cloud, etc., is being presented over here. Before that, just this presents the importance or the interest, research interest you can say, or the practical commercially available systems interest you can say, that this is the global distribution of IoT projects throughout America, Europe, and Asia Pacific regions over the different type of applications. And there you can see that the most of the investments or most of the projects are dominated mostly by America. And in case of the global share of IoT projects, like the investments and all, or the type of rather type of application, here the industry-based applications are more, and here is the position of the connected health or the smart health that I am going to illustrate in few of my next slides. Now, just to implement, we can go through these available IoT platforms, and these are the IoT connectivities that are short range and long range, both communications that are required to transmit the data at the sensor layer and as well as to the through the long range communication to the cloud end. So what is the target? Target is the remote monitoring or health monitoring, you can say. Basically, this monitoring can lead to disease prediction or leads to disease prediction. And here we focus on the monitoring part. And what we do actually is that unattended monitoring means without intervention of any human being, and remote monitoring means like physically the person need not to be to be present at the same location of the person who is getting monitored. So prototype 1 that we have implemented in our IoT laboratory is a location aware smartphone based fall detection system. So the sensors we are using are smartphone sensors, specifically the accelerometer and gyroscope, and here the purpose is for fall detection. And what has been done? Fall detection based on accelerometer data. And while we can detect the fall, it will give the fall exact fall time and fall location. And it will send the distress SMS to close relatives, means whose mobile numbers are registered. And it can store all the data for further clinical diagnosis. And it has been successfully implemented on Parkinson patients to reduce fear of fall. So we have considered a factor, fear of fall. Why it has been considered? The Parkinson patients, actually they are prone to failure. And due to that fear, that prone to failure fear, they are not willing to walk or move much without manual support. But to enhance the rehabilitation process, or to increase the level of confidence, rather, like if you can reduce the fear of fall, that means you're increasing the confidence level. If you can give some sort of confidence that if you fail, then immediate care will be taken, then obviously it will reduce the fear of fall and it will increase the confidence. So from that point of view, we have implemented this on the Parkinson patients. This is the framework actually that we have implemented. And basically, I'm not going into the detail. Rather, what is actually the basic raw sensor data is the accelerometer data. So there is one live fall detection module, and another is the GPS module for the location identification. And what different classifications we have applied the machine learning algorithms, and what sort of classifications can be done. Like it can be a classification like fall, where a fall has happened but no recovery, means after failure the person is not able to recover. So that means the person's posture has not changed after fall. Fall with recovery means the fall has happened, but then the person is able to gain his previous position. So that means fall has happened, but with recovery. Recovery has been taken place with a stipulated period of time. Now, sometimes this fall can be confused with stumble or fast sitting. So that also we have taken care of. And ultimately, what comes to the relative's mobile phone is a message is this message, like a fall is detected, particular date, particular time, and the particular location. So with that, if the person is assured that if someone is very nearby to me who can just come and attend or give support, necessary support, if any fall event occurs. So that is the prototype 1. And another prototype 2 that we have done is smart walking assistance for elderly care using an intelligent real-time hybrid model. So basically what we have done here, actually the device that a person need is to have a smartphone, because the smartphone accelerometer sensor we have used. Now the same thing we have tried in different way, because the elderly people, maybe Parkinson's patient or maybe any person, they have a walking stick. They need to carry. It is a necessary thing. Now, if we can convert that into smart device, then that is not any additional device he or she need to carry. So it can be more usable. From the usability point of view, this prototype has been built up. And here what we have done is fall detection based on accelerometer data, and posture detection based on accelerometer data and gyroscope data. So here the applying the machine learning using random forest machine learning algorithm, we are identifying posture as well as the fall. And periodic location means we have set a regular interval of 2 minutes and the posture for 10 seconds for the detection. And along with this, another feature we have added, that is fall time, fall location, and the pre-fall posture, means before fall, what was the immediate posture of the person. Why this is important? Because the ultimate task that is going on associated with this is the disease prediction or the disease identification. So if the pre-fall posture can be noted at every fall, then the specific disease detection or the disease prediction would be helpful. And a warning message will be given at the monitoring station, and distress SMS will go to the close relatives. And all the related data are being stored for further clinical diagnosis. So how the prototype looks like? You see that in the walking assistance or the walking stick, these two modules we have embedded. These are ESP8266 and MPU 6050. So these two modules are being embedded in the stick so that it can be converted into a smart walking stick. And the raw accelerometer and gyroscope data are being sensed. The data are pre-processed. This is the standard practice. And after that, it is going to the live posture identification module. Why we are saying the term live? Because data streaming is done. Not that data is stored somewhere and then fetched. No, it is a live streaming of data and live monitoring. And then live fall detection module. Module is done for the fall detection, and so both way the simultaneous monitoring is going on with the streaming of data. Not that data is being stored. This is the unique contribution, and that must be there for the monitoring of or health monitoring. Like it should be live or based on the streaming of data, not data stored and then fetching. So with this simultaneous monitoring, one with the fall detection, another with the posture detection, we are going for ultimate detection of the fall event if occurs with pre-fall posture, like before the fall, what was the posture of the person, and then the time, location, and date. So with that, the specific information, these clinical data are being stored maybe over a period of time, and the person is getting monitored, and the data can be clinically analyzed by the expert parallelly, so that it can help in the disease prediction. Now here it is the connection that is we have done, and with this this is the another variant of this model. So I'm not going to just another variant, and ultimately this we are being achieved, that what exact message is sent to the relatives or the registered mobile numbers through SMS gateway. We are sending this through SMS gateway because there will be no dependence on the internet connectivity, which may be always not available. Like a fall is detected from standing position at the particular date, at the particular time, and at the particular location. Now, we have applied 4 different machine learning algorithms, and we are achieving the best result with the here it is shown that, and this is the change in the accelerometer data, like whenever we go with the different fall event from the particular posture, like if it is from laying or sitting or standing or walk. So this is the accelerometer signal presentation, and this work has been published in one of the reputed journal of called Evolving Systems with High Impact Factor. And also we have achieved 2 international patent grant, Australian patent. It was awarded in 2021 based on this prototype building or this contribution of the smart walking assistants. So what intention behind this presentation is that the IoT based smart applications are or can be realized or implemented for the societal benefit, for enhancing the quality living, specifically the elderly people, like because we know the statistical data that the elderly people are increasing, like over the 60 age is increasing worldwide, and as the for the prolonged treatment or the prolonged monitoring rather, now manual intervention may hamper privacy or maybe somewhere not available, may be associated with the cost. So several factors can be there. Now, if some automated support can be given to some extent, and here the IoT comes as the extension of the human being, not the complement, because these IoT-based smart healthcare or these kind of things are not going to replace the traditional healthcare, but it can be in support of the traditional healthcare, just because we all also aware that the infrastructure support in the health infrastructure support or the health professionals are much scarce than the demand or the need in our country. So this kind of applications can be achieved and can be applied for the societal benefit, to enhance the quality living, to support the elderly people, or to support the diseased people with the level of comfort and with the automated monitoring. And with this, I would these are the references that I have taken help, and some these are the papers that are being published in the good quality HCI journals in Springer Elsevier by our research team. And with this, I must acknowledge the IEI Tripura State Center, Engineer C. Devnath, FIE Chairman, IEI Tripura State Center, from whom I got the invitation email, and also Honorary Secretary Dr. S. Bhattacharjee, FIE, and Dr. Vijay Kumar Upadhyay, Chairman, Computer Science and Electronics and Telecommunication Engineering Division, IIT Tripura State Center, who has communicated me regarding this talk, and also the one and all who are associated in organizing this wonderful event, and I am thankful being part of this. Thank you. This is my email ID. So if any interaction or any question.
Thank you, madam. Thank you for your illustrious presentation on IoT-enabled smart applications, especially focused toward the healthcare. Now, we like to invite our next speaker, Sri Prakash Bormon, who is Block Informatics Officer, Government of West Bengal, who will be presenting his topic on Internet of Things implementation. Over to you, Sri Prakash Bormon.
Thank you, sir. Thank you, the organizer, Institute of Engineers, Tripura State Center, for giving me this kind of great opportunity to be a part of this great webinar. And also, I'm learning from Shuparna ma'am, and also I learned from Shreya Dev sir from their valuable lectures. speeches. Shall I open my, share my presentation? Just a moment, let me,
Yes, please.
yes. Is my screen visible?
Yeah, screen is visible. Please make it full screen. Yeah.
Okay, thank you. Today, this is the session on recent trends in Internet of Things, and I will talk about Internet of Things implementation. Actually, in this presentation, I will represent some basic concept of Internet of Things. Means how the Internet of Things can be developed. This is the outline of the presentation. Let us first go through a video.
Do you think an orchid will ever be able to tell its story? Do you think a flower will one day tell us where it was grown, how it was treated, or how it got here? Do you think it's possible to teach traffic to speak? Do you think a car can call an ambulance faster than a phone? Do you think it's possible for devices to automatically deliver important, often life-saving data to those in charge? Can you imagine an ambulance that gathers critical information before arriving at the hospital? And that a patient could be examined before he even enters the emergency room, saving precious time for the patient and his family. None of this is science fiction. It's all part of a concept that our team has been working on for several years.
So that was the video which shows the future actually. Actually, with the Internet of Things, we can get this kind of future. Now, some commonly devices in our daily life, which can be tell as a smart device or IoT device, like as Amazon Echo Plus voice controller, Philips Hue bulb, smartwatches. Most of us use nowadays we use smartwatches. These are the components which can be used in the for IoT operation to develop a IoT device, like as computing board, sensor, display, switches, relay, breadboard, servo motors, and transmitter. For our case, we will use, means in most of the cases, I use basically Arduino boards. These are the small computer, tiny boards, tiny computing boards. Arduino, Arduino, there are various types of Arduino available in the market. This is the pin layout of the Arduino board. There are some digital input and digital output, and also there are analog input output, analog input and digital input or output pin layout, and there is power pin, and this is the USB connector. Through these we can program this board, and this is the power voltage input, means with this we can make it alive through a battery also. These are sensor. This is DHT11 or DHT22, which is used to measure temperature and humidity. This is very tiny. This is also a sensor, kind of sensor, that is ultrasonic ranger used ultrasonic wave to determine distance of object. Generally, in case of robotic development, this kind of ultrasonic rangers are used. This is a LED display. This is a tiny switch, a relay switch, breadboard. This is servo motor. This is transmitter. Transmitter and receiver. This is also transmitter and receiver. Transmitters. Now, that was the devices or tiny devices which we can use to develop a Internet of Things device or smart device. And now we will get into the programming part. For programming the Arduino devices, we use Arduino IDE. This is the fast interface of the Arduino IDE programming integrated development environment basically. And in the Arduino IDE, programs are called sketches. This is a very simple program. It is an example program which I have opened here, and there are various menus. You can find various menus. Now, if you want to make a temperature and humidity Arduino IoT, then we need Arduino Uno board, small breadboard, DHT12, which is humidity and temperature sensor, ESP8266 Wi-Fi serial module, some breadboard wires to connect the pins. This is the pin layout by which we can connect the Arduino IDE with the breadboard, and from the breadboard, the DHT22 will be connected with the Arduino board. And again, this ESP8266 is connected with this Arduino Uno board to transmit the data collected from DHT22, that is the temperature and the humidity data. Means after collecting the data, temperature and humidity data from the DHT22 sensor, it will process the data and send it to the data to the ESP8266 module, and through the ESP8266 module, it will be transmitted to the cloud basically for displaying. This is DHT22. It has 4 pins basically, voltage, and the second pin is used for data, third pin is not used, and fourth is the ground pin. This is circuit of ESP8266. This is the basic circuit. And this is freely available cloud server, which is thingspeak.com. You have to create an account over here, and after that your data can be transmitted into the cloud. In the ThingsSpeak, we have to create a channel, and the channel you can name it. The channel, and number of fields which you want to enable. You have to put tick over here. And after creating a channel, you must get a API key. This API key has been marked because it is used for someone else. You will have to copy your own API key and keep it anywhere else for the programming part, because in the programming you need to embed this API key. In the programming part, for this means Arduino weather station or temperature humidity weather station, you have to define this SSID, that is your Wi-Fi details, through which your device will communicate with the cloud. You have to put the SSID, then the Wi-Fi password, and the API key which you have got from here. This API key has to be inserted here. After that, your device will be can communicate with the cloud, and the data which will be collected by the DHT12 shall be transmitted to the Arduino board, and after that it will be transmitted through the Wi-Fi to the cloud. Let's see the programming. This is the Arduino programming. It's very easy and like as C programming. See, we are using GST pin 2. So we define there and define the name also, as well as this is the SSID. SSID, that is your Wi-Fi SSID, then password, and this is IP address of the thingspeak.com website, that is cloud, and then we have to put the right key, API key over here. After embedding everything, after completing the programming part, if we connect the power with the Arduino board, this program has to be uploaded into the Arduino board. There is an option in the menu to upload this program into the Arduino board. After uploading this program into the Arduino board, and if every connection is in a good condition, if there is no loose connection and everything is okay, then we can view this kind of output in the website. ThingsSpeak, we named it ThingsSpeak Web, and we will get for example, field 1 that is temperature, and field 2 that is humidity. I added a GPS location over here. That GPS is not collected. That GPS is not collected from the device itself. It is embedded only over here. So we can get this kind of output, and this period will be this graph will be increased dynamically. And this is the mobile view of that particular website. There is an app, ThingsSpeak app. In the ThingsSpeak app, you can get this kind of output also. In the serial monitor, means in the computer part, in the laptop or computer, we can get this kind of output. See here the humidity, and this is the temperature. When I recorded it, this is a recorded one. See, the temperature is increasing. I was using some air blow over here, so that was increasing. The temperature was increasing. So next, we are getting into the smart home concept. I will just show how a switch can be automatically on or off. Just simple concept. This is the Arduino Uno board, and this is a relay switch and simple bulb. We connect the pin number, analog pin number 4, 5, 6, 7 with this one, means with the relay switch, and we put the power 5 volt over here and the ground from here. Let us see the code. This is the code. I only want to, there are 4 relay switches over there. I only want to enable one switch because I will use only one device or electronic, one bulb over there. So I used only one bulb, and another part I put in reminder. And this is very simple code. Digital write relay control 1 high, that is it will send a high signal to the relay switch, that is relay control, this one, relay control 1, number 1 switch. It will send a high signal, and the switch will be kept on, and again it will send a low signal. After some time, after some delay, it will send a low signal, and it will keep the bulb will be off. This is the actual protocol, and After that, when we upload this into the device and all the things, if we connect properly, then it is recorded at my home basically. I just put this in a loop, and the thing is automatically switching on and off. So if we put some logic on this, then it may be possible. It may be means if there is a sensor, then that when we are entering at my house, entering at our house, then it will be the light will be automatically switch on. So that can be made with this thing, with these devices. So this is a simple thing which I have shown. So this was my actually implementation demonstration only. Actually, I'm also a learner. I'm a PhD student of University of Calcutta right now. I'm a learner again, though I have two published patent with the Patent Authority of India. And now if you have any question, then I'm ready to answer.
Thank you, Sri Prakash Barman, for the nice illustration and a hands-on experiment on this IoT application. As our total system of questionnaire and others, we are keeping here as it's a hybrid mode. So we are collecting the questions and we'll share afterwards if there is anything. Thank you once again for this illustrative presentation.
Thank you.
May I now request Dr. Abhishek Mojumdar, Assistant Professor and Head CSE Tripura University, to present his talk.
Not working actually. Good evening, everybody. So thank you for calling me in this webinar and giving me the opportunity to talk in front of you. So I'll not be focusing on any particular topic. Actually, I'll be touching on many things, that is trends and challenges. Both what are the recent trends and what are the challenges we have in case of internet. So these things in short I'll touch, so that people who are interested, they can work on that and they can get some output out of that. So this is the outline, some brief introduction. Already the previous speakers have said about that. Why actually IoT is needed, then IoT technologies and trends, then benefits, some of the applications. Already previous speakers have said a lot of applications. Then industrial IoT I'll touch upon a brief detail. Then what are the needs to be done, what needs to be done, then research challenges and security challenges. So these things actually briefly I'll cover. So previous speakers have also said about the IoT, the definition of IoT. IoT is actually interaction between physical and digital world. Now the question comes how the physical world and digital world interact. They will actually interact through sensors, through actuators. Through sensors they will collect data, and through actuators they will act. So that's actually your physical world and digital world communicate. Now the thing may be anything, anything means anything. Your mobile phone, heart monitoring system, smart watch, smart shoe, smart dress, anything, everything you add smart means any entity you add smart with that becomes connected and it becomes part of Internet of Things. Now IoT is a sensor of network of billions of smart devices, sensors, other types of devices, laptops, smartphones, computers, servers, lot of things. It's not only sensors. So a lot of different entities are present in case of sensor, the IoT. So it's a giant network, and the storage and processing can be done at the edges, as the first speaker has said about the edge. So all the IoT devices, whatever present, so they do not have enough computing facility. So the computation can be done at the edge level, not at the cloud level, but at the edge level. We'll have a diagram, so you can look into it. So communication between IoT devices are mainly wireless, but it doesn't mean it will only be wireless. It may be wired also. It may be wireless also. Most of the cases wireless. Now this actually shows the growth of deployment of IoT devices. Now as here you can see, the growth throughout the year has increased drastically, and in case of industry and entertainment, it has increased very, very fast, though it's not the very recent up to 2020 Gartner data. So but it is actually showing the trend. So from here we can understand the necessity or the investment which is actually done in IoT. Another slide. See, because of COVID, our economy has suffered, everything has suffered, but now whenever the question has been asked whether they are going to increase the investment on IoT or not, the companies have been asked, and Gartner has performed a survey. So there it has been observed that about 47% companies said they have increased their priority for implementing the IoT. Most of the companies have increased their priority because of COVID also, or without COVID impact also. But result is this, that 47%, most of the companies are investing on IoT, and they are increasing their dependence on IoT. Now why IoT? Now organizations in a variety of industry using IoT to operate more efficiently and better understand the customer. See, whenever everything is actually related to money. If something doesn't bring money, that technology is of no use, because ultimately industry people will invest. Now if they do not get money, they will not invest. Government also will do the same thing. If it is beneficiary, then only they will invest, otherwise they won't. Okay, so it actually benefits the organization to track these customers and to check what are their preferences, what are their recommendations. Everything they will see. Like our mobile phone, suppose you have searched for a electric fan, suppose in Google, immediately you will see, after some time in your Facebook account also you will see advertisement for a fan. Now how they know? So you are being monitored. That is the fundamental thing. Every time whatever you are doing, your web browsing, that is being monitored, and that is being used for sales purpose. Now suppose if you have some interest on fan, ultimately some fan color you like and you will buy. So that is their strategy. So deliver enhanced customer services. Of course it is enhancing the customer services, and improve decision making, what to do, why not to do, what not to do. Like in early days we used to see this, in case out of the supermarket or any big bazaar or somewhere, some people were standing with some cheese. If you fill the form, then you will get some reward, some prize, something. Okay, nowadays we don't see much. Now how they are collecting the information? They are actually collecting the information by giving cashback. Now if you use this wallet, then you will get 50% cash, 50 rupees cashback. Now that is very cheap actually, 50 rupees to one. Now otherwise you would have employed one person outside a shopping mall, and he would have been busy for the entire month or year. So your investment has also decreased. More efficiently you are using the resources. So that is the benefit. So increase the value of business. Your business value will also increase. like IoT device, these are not single standalone devices. Now, like it's that one device is there, still it's working, and you are running some program on that. It's not like that. So it cannot survive alone. It has to be in some ecosystem. Means collection of systems should be there for this system to work. Now, what it may contain: embedded processors, sensors, communication hardware to collect data, and some data acquired from the environment. So sensors are required for collecting the data. Then IoT device will share the data to the gateway which connects it to the internet. Okay, and then it will be sent either through edges also, it can be processed, or to the cloud also. So like, see, like in this diagram, we can see that from sensors, different kind of data, this car related data, factory related data, this power related data, a lot of data has been collected. Now they are first sent to the edge. Now if the processing is not that heavy, and the result needs to be immediate, means not much delay you can tolerate, so at that case that will be processed at the edge. Now question comes, what is edge devices? Edge devices may be anything which is more powerful than your sensor processor, like your mobile phone, maybe smartphone, maybe laptop, maybe Raspberry Pi, maybe anything, or some lightweight servers, anything. Then if that thing is not possible, that computation is not possible at that level, then it will be sent to the cloud. So there it has enormous amount of computation, so it can compute the job. But problem is that reaction time is more. But in case of edge, the reaction time is less. So that's why edge is used. Now, what are the trends actually? What actually is happening because of this IoT? First is AI. Now, see, the data, you are getting lot of data. Suppose you have clicked lot of picture. Now, what does it mean if you do not use it? Now, AI actually uses this data. Using this data, it will infer the information. It will derive the information. What is the habit of that? Suppose you are a buyer, frequent buyer of item A. Now that you are buying item A, that information will be sent to the server that you are buying A. Now you are frequent buyer of A, that will be derived by the AI. It will analyze and it will find out that you are frequent buyer of A. So A should be shown as an advertisement in your Google account. Whenever you open some page, it will be showing your advertisement. Now social, legal and ethical IoT. See, whenever you are using the IoT devices, what is actually happening? You are sharing lot of private data also, like in our mobile phones. Whenever we are registering for some site or some app, they ask for permission. We see the permission, we tick all the permissions, then it gets installed. Now what does it mean? You are giving all the data, most of the data, whatever data required, to the server. Okay, so now that data may be misused. Now you are giving some data that may be misused also. So that is the ethical IoT. And legal means whenever you are storing something like your Gmail account or your Google Drive, you do not know where data is stored. You are relying on that, but you do not know where data is stored. Whether it is in India or in outside India, you do not know. You don't have any idea. So now as the jurisdiction of the data changes, the law of the land also changes. Now Indian law, if data is stored in US, Indian law will not be applicable on that particular data. So that is a problem. Another is infonomics and data brokering. See, whatever information companies have started to sell those information. So that is part of economics. They can earn from that. So that is one aspect, one of the trends. Then IoT governance. Now you are storing something in the IoT, you are sensing something, but no fixed rule, no governance has yet been decided. There are loopholes people can misuse. So that also needs to be decided. Then sensor innovation. See, nowadays, lot of sensors every day are coming, more advanced sensors are coming. People are using more advanced sensors, sensibility wise also very high. So that is also another trend. Then trusted hardware and operating system. So a lot of computers now, IoT devices are coming with the coupled hardware and software. You don't have to install software separately. So that will increase the trust. Then silicon chip innovation. You have a lot of microprocessor chip which consumes less power, because problem with the IoT devices is that they are all battery run. Now if they consume a lot of power, then it will be exhausted very fast and you won't be able to use it. So that is a big issue. So your system should consume minimal amount of energy. So now for that, you require some specialized chip which reduces the energy consumption. Now new technologies has to be adopted, like 5G has come already, 6G people are working. Now 5G has already come, so it has to be adapted in IoT in their communication. So these are the trends actually. Now these are actually through one diagram I've figured out few of the benefits I've taken from this source. Now here you see these are the benefits IoT is going to offer. First is enhanced services. Services provided to the customers are enhanced. Means on a fingertip you are getting every information. So that is the benefit. Another, improving well-being, like previous speakers have said about smart healthcare. So that is one of the benefit. Then generate new revenue. Lot of revenues you can generate. Lot of revenue you can generate using minimal amount of resources. And increase engagement. You can better engage with the customers. So these are external, not means internal to the organization, but with respect to internal organization. So optimized asset usage. So whatever your asset is, those will be used in an optimized way. Means it will not be over exhausted, not be under exhausted also. Then improve security. Your security system will also improve. Then enhance. Okay. Okay, reduce expenses. So it reduces expenses. So whatever the expenses are, it gets reduced. So you can reduce it. And conserve resources. Like you have this limited set of resources. You can, if you can use it efficiently, your resource will be utilized better. Now, these are the usage of IoT. Lot of fields you can use. Now, first one is transportation and logistic. Like in your transportation system, if you fit GPS system in every truck or in every transportation vehicle, then you can easily monitor where the thing is, where the shipment is. You can easily monitor. So that way you can use the IoT. Then energy, like every day nowadays in our homes also the smart meters are there. Now through smart meter you can check the energy consumption from the power department itself. People don't have to go at your house and just check the bill. Then smart city. So smart city, we are implementing smart city. So a lot of things, traffic and all, everything will be automated. Then health, madam has already said about health. Then environment means what is the environment condition, what is the carbon monoxide level, what is the carbon dioxide level, everything on you can monitor using IoT. Defense, of course, nowadays lot of defense usage you will see, swarm robots and all, everything, every defense system are IoT enabled. Then in industry, industrial IoT is there. Then aviation, earlier also there, now it is rapidly used. In fact, nowadays people are using drones. So in case of aviation also a lot of IoT usage is present. Then education, yes, in case of education also VR you can use. Then augmented reality you can use, smart glasses you can use. So attendance, automatic attendance system you can use. So these are the usage in the case of education. Agriculture, lot of usage, the pesticide usage and everything. Then home also, smart home facilities we can have. So this is a diagram showing a system of this IoT. Everywhere you'll see IoT, from shipping to structural to parking to traffic light to building. So every term, before every term you put smart, nowadays that is smart. You put some sensor, you put it smart, then that is a smart thing, and that is IoT. So these are the few consumer devices. Medical alert system. Lot of expensive watches are there. They can predict, even Apple watches are there. They can predict even the heart attack also 1 second or 2 seconds before. So then guidance sensors are there. Then Amazon Dash means if you require this particular product, you simply click on this and order will be placed. Then smart running shoe, you can have running shoe which will monitor your foot, how you keep your foot and everything. Then smart TV, smart fitness cloth. If you wear the cloth, then how your muscles move, what is the movement. So those things are available in the market. These are nothing new. So those are available in the market. If anybody wants, you can purchase. Now, usage of IoT in agriculture. So this is the usage of IoT in agriculture. So here we see the irrigation information. the irrigation is done using IoT. The soil information is being sent to the decision support system. And then if soil is dry, then irrigation will be done. Through irrigation, the resources can be, water can be utilized in a better way. And this production also will be good. Then in case of IIoT, so IIoT also, if we see in the industry, every device every machine is connected to IoT. So that is industry 4.0 also. So industrial revolution, that is industrial revolution. So digital factory. So it will actually enable each and every machine to send its information to the manufacturer as well as the field engineer. So that is one facility. Another is facility management. Suppose if some system is facing some trouble, it's not routine servicing, it's situation based servicing. If some situation arises, from sensor you get some records that the system is not performing well, so you can repair it. Then product flow monitoring, from refining to delivery of the product, you can monitor it through tracking. Then inventory management, how many products are coming, how many raw material is coming, how we are processing it, so it will monitor across the weight. Then safety, if there is some threat in the system, in the boiler, suppose in the industry there is some boiler, so their sensors are fixed. If the temperature increases beyond some limit, so it will warn and it will safeguard the workers. Then quality control, through that you will get, through the sensors will get a lot of data, and by analyzing the data you can check the quality of the product also. Now these are the things which needs to be done. The consumer education, so consumer education is very important. Like everything, like we use smart TVs or we use smartphones, right? They have cameras, they have speakers, so that is very much vulnerable to the attacker. So means they can hack your camera of a smart TV and see whatever you are doing at your home. So that is, consumer education is only one way to counter that. Then product reviews and comparisons, you have to, product reviews needs to be done, and the comparison with some other product equivalent products also needs to be done, because there are a lot of products in the market. Now which one is better in which respect, or which one is the best product out of all, so that comparison should also be there. Then vulnerability disclosure, what are the vulnerability means, what are the loopholes that attackers can use, that should be disclosed. Then self certification should be there, like this TV is BEI certificate 1-star, like that some certification should also be there. Then government initiatives should also be there to frame the guidelines for using these kind of devices. Then mandate security requirements, this mandate certificate and liability. If there is some problem in the system, who will be held liable? So that also needs to be decided. So these are the research challenges in case of IoT. The first is poor management. See, in case of IoT devices, you have a lot of devices and a lot of resources. But since it's a big network, it's very difficult to manage all the devices. So this is a big challenge, and this needs to be resolved. Another is big data. See, a lot of data you are getting from the sensors. Now, these data you have to store somewhere. So that is, handling of this data is not a small issue. Thousands of data, millions of billions of data you are getting. So now how to handle that data, that is a big issue. Another is energy efficiency. Like you are using IoT devices. These are small devices like your smartphone. Your mobile phone charge lasts for maximum 2 days, not 2 days, 1 day maximum. So now other small devices also, if they are consume so much of energy, who will replace the battery every time? So that is a very critical issue. Now how to make a system energy efficient, because if the system draws a lot of energy, then ultimately your objective of making a smart device is nullified, because after some time it will be dead and it will be of no use. You have to replace the battery. Suppose you have put some sensor in the border area. Now a lot of firing is there, everything is there. Now if the sensor consumes a lot of energy, what will happen? Your soldier have to go there in the border area and they have to again change the battery. So that is very critical issue. Another is security. So security is very critical. See, security has been taken care of in case of traditional devices. We have a lot of algorithms for that, but those algorithms were developed when considering the scenario was that you have a computer, you have a processor, powerful processor, so it can process it. But in your case, in this case, what you have actually, you have a small processor. In case of Arduino, its processing capacity is very small. Raspberry Pi is better, but not as good as your i3 processor also. Okay, so it's very big requirement. In security, you have unauthorization. Unauthorization means unauthorized users will get access. So that is a problem. Identity management, lot of devices are there. How to assign the IP, how to manage the IP, how to maintain which device is that particular device or not. Then data communication. Now, see, after all, you are sending the data, you are receiving the data. If you do not send it, then what is its use? So you have to send that data also. So data communication, security also is also very important. Then storage, you store the data. As I have said, you are storing the data with a good faith that in my Google Drive data will be safe. But is it safe? So that is the problem. So that is the question. Now the network, it's not that only wireless network it is used. Wired networks are also used in case of IoT. In certain devices they are used. So how to ensure the security of that particular network? So that is also research challenge. So these are the research challenges, security challenges of IoT. First is data integrity. So data integrity says that whatever data we send, whether that is received as it is, means whether there is some alteration in that data or not. Suppose you are sending patient data or some critical data, okay, and on the way it has been altered. Suppose the patient is critical, but on the way it has been altered and it has been set as the patient is normal. So ultimately the patient will die because no action will be taken. So data integrity is very important. Another is encryption capability. See, smart devices are there, but they do not have enough processing capability. But this doesn't mean that we'll send information unencrypted. So it has to be encrypted. It has to be encrypted through some lightweight encryption algorithm. So there is huge scope of working on that. Then privacy. So you are storing, see, whatever data you are storing in case of IoT devices, your heartbeat, your pulse rate, your everything, that is very private data. That should not be disclosed in public. So that is your data. But how to ensure that privacy? That is very important. Then connection framework. See, there is common framework. See, there are a lot of standards, lot of things, lot of devices are there. But till now, there's huge scope in development of the framework, how actually they will work together. Then automation, like we make system automated. But of course, after that, we have the trouble of security. At any portion, it can be hacked, and the automation can malfunction also. Then upgradation, you devise some system, install some system and keep it for years. It should not be like that. Okay, you have to upgrade it. And then security. Now, whatever data you are actually here, security, I'm meaning to everything belongs to security, but security, I'm meaning to this access control. Whatever data is there, it should not be accessed by everybody. It should be accessed to some particular entity. Like in a bank, the cashier cannot access the data, amount of data the manager can access. So he has some limited access. The manager has bigger access. The senior manager has a bigger access. So like that, access control should also be ensured. Now, in case of IoT, these are the challenges, almost similar, but see, communication is there, access control already I said. Then device performance, like you have designed a system, you have designed an algorithm, very good algorithm, performs very well, but your processing speed cannot handle this. So your processor cannot handle this, your processor becomes hot, and after that, this gets damaged, or your battery gets exhausted. So that is the problem. Then privacy of information, already I said. Then confidentiality of the information. So whatever you are sending, that information has to be confidential. Like in IoT, industrial IoT, means suppose some machine parameter, critical machine parameter, to the rival company, it should not be disclosed. So it should be concealed also. Then heterogeneous networks. See, in case of computer networks, we have laptops, we have computers. Okay, so all similar kind of things. But in case of IoT, we have smartwatches, we have ACs, we have Alexa, we have laptop, we have many things. Okay, so heterogeneous, lot of things. So you have to manage that also. Then multiple jurisdictions, like your data, as I have said, that your data is being stored in US. So jurisdiction changes. So that is a big trouble for you, because law changes. Indian law will not be applicable on that. If somebody says, I'll take away the data, Indian government cannot do anything. So that is a big issue. Then another is service integration in IoT application. How you integrate the services in the IoT application development. Then data availability. Suppose you have stored some data, but accessing that data is very difficult. So you have to maintain the availability of the data also. A lot of encryption you have used. So much encryption anybody cannot use. So even legitimate user also they get very difficult to access that information, or you have stored it in particular one server only. That server gets down, so data is now unavailable. Then trust in case of IoT devices and infrastructure. So trust is very important. Device to device trust is very important. If that is not there, the entire system will collapse. So trust is very important. Now, can you please play the slide? But IoT is not always very good. It's not that, yes, there are benefits, but there are downsides also. Can you please play the video? So you will see a commercial only. So this will reflect the downside.
Open door. Door open. Radio on. Playing radio. Lights. Lights on. Protein shake. Making protein shake. Loading New York. Speed. 4. 6. 16. 4. Collection 16. Lights down. Only 16. Only 4.
Fra en klassiker til en annen, her er Summer of 69.
69.
Her er neste låt, også en klassiker.
74. 75. You are breaking the world record. 75. 4. Louder, please.
Det trenger ikke være komplisert å leve sunt. Ikke trenger det å være dyrt heller.
Open door.
Roll voice command.
Rema 1000. Bare lave priser.
So thank you. These are the references. Thank you all.
Thank you so much.
If you have any queries, you can ask.
Dr. Abhishek Majumdar, Assistant Professor and Head of CSC, Tripura University. Ladies and gentlemen, that was a really wonderful and very immersive session. And we have heard a lot of expert speakers, including our chief guest, and different opinions and views. One thing is for sure, that any science and technology must be taken up to its know-how in the ground to the usable level, otherwise it may be a disaster. May I now request Engineer Taposh Bhattacharya, Advisor, Computer Science and Electronics, Telecommunication Engineering Division, IEI, Tripura State Center, to present his speech. I want to take all your attention, please. So now we are having a scheduled question hour, and that will have only one question: how we can differentiate between bending and fall. The question is open here. Any expert from our today's panel can please answer it. Okay. So the question is placed to the expert speaker. They can prepare it by now. Due to some medical emergency, Engineer Taposh Bhattacharya is advised to remain silent, and he has placed his speech. May I take the privilege to read out his speech? Namaskar to all, respected past President IEI and Executive VP, WFED, Dr. Ashok Vasa, other esteemed dignitaries, good afternoon to you all. I was extremely excited to share my feeling quickly in this significant event, but unfortunately, I'm advised voice rest. Today, I stand before this galaxy of engineers attending the webinar to express my heartfelt thanks and gratitude to the chairman and honorary secretary of my center for giving me this opportunity to share a set with all the luminaries here online and offline. The topic chosen in the webinar, the recent trends in IoT, is the first example of quality of our electronic telecommunication and computer science division team, which is always found runner and deserve a big round of applause for selecting right topics in right time. It would be mere an audacity to speak a single word about the topic in front of all the professionals and academia who have mastered the subject. Our ETCS division, head by Chairman Dr. Bijay Upadhyay, Vice Chairman, and today's special guest, Dr. Mrinal Deburma, the unparalleled, most dynamic performer and hardcore technocrat, Dr. Suman, who is the brand ambassador of any prestigious and academic institution or industry, deserve all appreciations. The speakers today is highly acknowledgeable and deliberated rich content on the theme. I express my heartfelt thanks to chief guest and special guest of this afternoon here. Without the support and cooperation of IEI headquarters, Honorable President IEI and Chairman of all respective divisions, these week-long programs of us could not have been organized. At last, I, from my personal behalf and on behalf of my division and center, express my heartfelt gratitude to all the stakeholders present online or offline, what whose presence it would have miserably failed. Before I conclude, once again I congratulate the team of Electronics, Telecommunication, Computer Science Division of IEI. Thank you, one and all. IEI, long live, engineers fraternity, long live. Thank you, Engineer Tapash Bhattacharya, Advisor, Computer Science and Electronics, Telecommunication Engineering Division, IIT Tripura State Center, for expressing the views, even though his limitations in speech, for some time only. Now the question hours are open, and we have one question. I will request all our expert speakers. Anyone, please, can address to this. This question is meant for Dr. Suparna Bishwas, Associate Professor, Department of Computer Science and Engineering, Maulana Abul Kalam Azad University. We can find that Dr. Bishwas is somehow, for technical reason, maybe disconnected. Okay, so just to abiding the time constraint, we have sent these questions for to be answered by Dr. Suparna Bishwas, and we would request whoever is placed the question can have a communication with Dr. Bishwas as the address been prompted there. Proceeding to the next, the summarization of today's whole event. It is a privilege on my own behalf as the moderator of this program to summarize the whole activity, what happened today this afternoon. Definitely, it was an eye-opening start by the welcome address of chairman and thereafter the chairman of Computer Science and Engineering Division, which was highly enriched by the speech of Engineer Ashok Kumar Basha, President IEI, and the more technical session and more technical inputs, which was ignited by our chief guest speech, Engineer C.K. Dhar. There, the theme of today's this one-day seminar was highly impetus on every audience that how this can be connected to our everyday life and how it can be taken further. The presentation by Dr. Sujoy Dev was quite illustrative in terms of usable IoT, where the Indian scientist can put a footprint on the IoT field in terms of designing and in terms of fabricating the hardwares. It was really a very appreciable matter that Indian scientists are now coming up in the forefront and making an Atmanirbhar hardware. What today I got a very nice theme for all of us here as engineer, student, and researcher. Dr. Dev's collaboration and the progress is definitely a highlight in this particular seminar. Thereafter, Dr. Suparna Vishwas, Associate Professor, Department of CSE, she has presented a very nice smart application, and that was an assimilation and it was an illustration of different application altogether in her presentation. One point we can all derive that IoT is not only for device, but IoT is a thing for human. And that particular part was really ignited by our chief guest. Sri Prakash Barman has illustrated various hands-on activities, particularly in IoT. And we are thankful to Sri Prakash Barman for categorically recording and highlighting those IoT applications with the help of different ongoing applications in software level and also the hardware support. Finally, the presentation by Dr. Abhishek Majumdar on an at length discussion of IoT applications, different stakeholders in terms of hardware, software, and application policies was an eye-opening scenario for all of us. I wish that all the audience, including our very valuable the students and researchers, they can now find out their area of interest and capability through which they can extend their workability in terms of IoT application. Last but not the least, the whole assimilation of the work is a great takeaway for all of us on this thematic title, Recent Trends in Internet of Things. May I now request Dr. Shubhadeep Bhattacharya, Honorary Secretary, IE Tripura State Center, to express the vote of thanks. Ladies and gentlemen, we had one question which was meant for Dr. Suparna Vishwas. May I request Dr. Suparna Vishwas to answer or address the question, how we can differentiate between bending and fall. Dr. Vishwas, please. Maybe there are some technical issues.
Yes, there are technical
Anyway, the
issues,
question
sir.
been already expressed to the expert, the person who has placed the question. We would humbly request that please be in touch with Dr. Vishwas. Definitely, she will let you know the answer. May I now request Dr. Shubhadeep Bhattacharya, Honorary Secretary, IIT Tripura State Center, to present the vote of thanks.
Good evening to all. I, on behalf of the Institution of Engineers India Tripura State Center, express sincere gratitude to Engineer C.K. Dhar, Deputy Director General and State Informatics Officer, National Informatics Center, Agartala, who has given his precious time in this one-day seminar on recent trends in Internet of Things as chief guest despite his busy schedule. We also express our gratitude to Engineer Ashok Kumar Basha, past President of the Institution of Engineers India, Professor Dr. Girish Srikishan Mundada, Chairman, Electronics and Telecommunication Engineering Division Board of the Institution of Engineers India, and Engineer Sandeep Kumar Dev, Vice President of the Institution of Engineers India, who have graced the program today with their kind presence. We also express gratefulness to Department of Electronics and Communication Engineering, NIT Agartala, Department of Computer Science Engineering, NIT Agartala, and Tripura Institute of Technology, Agartala, for their support towards organizing this one-day seminar on recent trends in Internet of Things in association with the Institution of Engineers India Tripura State Center. We also sincerely acknowledge the guidance and support received from Electronics and Telecommunication Engineering Division Board of the Institution of Engineers India for this seminar. We are indeed thankful to our distinguished panelists, Dr. Sujoy Dev, Associate Professor and Associate Dean of Student Affairs, IIIT Delhi, Dr. Suparna Vishwas, Associate Professor, Department of Computer Science and Engineering, Maulana Abul Kalam Azad, University of Technology, West Bengal, Sri Prakash Bormon, Block Informatics Officer, Government of West Bengal, and Dr. Abhishek Mujumdar, Assistant Professor and In-charge Head, Tripura University, In-charge Head of Computer Science and Engineering Department, Tripura University, for providing their valuable time for this seminar. We are also obliged to Engineer Chinmoy Devnath, Chairman, the Institution of Engineers India Tripura State Center, Dr. Bijoy Kumar Upadhyay, Chairman, Computer Science and Electronics and Telecommunication Engineering Division of the Institution of Engineers India Tripura State Center, Engineer Taposh Bhattacharya, Advisor, Computer Science and Electronics and Telecommunication Engineering Division, and also immediate past Honorary Secretary of the Institution of Engineers India Tripura State Center, other eminent personalities present either physically or virtually in this one-day seminar on recent trends in Internet of Things. Besides, we are also indebted to all other dignitaries, senior engineers, council members of the Institution of Engineers India, officials of the Institution of Engineers India headquarters, past chairmen and past honorary secretaries of the Institution of Engineers India Tripura State Center, corporate members of the Institution of Engineers India, participants from various departments, academic institutes, and stakeholders, and each and every member of the organizing committee and office staff of the Institution of Engineers India Tripura State Center, whose active involvement and contributions have made it possible to organize the program. We also convey our special thanks to Sudeep Chakraborty, Assistant Director, Institution of Engineers India headquarters, for his wholehearted support towards organizing this seminar. Last but not the least, I also convey my sincere thanks to Dr. Suman Dev, Organizing Secretary and Assistant Professor of National Institute of Technology, Agartala, who has given his precious time for this seminar as moderator and program coordinator, and has made necessary arrangement for live streaming of the program from our center. Further, we beg to be excused for any unintended inconvenience caused during the program. Thank you all once again. Convey our best wishes for Bengali New Year to all. Thank you.
Thank you so much. By this, we have come to the end of this one-day seminar on recent trends in Internet of Things. Everyone stay safe. Thank you.
So with permission of the chair, I am ending the webinar here, sir. Thank you, everybody.